Well, good evening, everyone. Thanks for coming out on this November night. So it's my great pleasure this evening to welcome Professor John Dupre. He spoke to us once before in 2009, which is quite a long time ago. We should do it more often. He's recently done the Gifford Lectures to the Scottish universities, and he's director of the Organism Centre for the Study of Life Sciences based in Exeter, and he's also a professor of philosophy at Exeter University. So the subject this evening is something I don't know a great deal about, but that's what I'm here for, to find out. So maybe we'll have some fireworks.
Well, thank you for coming. I think the first thing I should probably say is something of an apology for my title. I will talk about the topic, the question in my title, but it will only be a part of the talk. I guess what I'll move straight on to is telling you what I will really talk about. So I hope you'll excuse me if I find it. Right, so here's the thing. So I want to start by talking about a really ancient and fundamental philosophical debate. Basically the question whether the world is a world of substances or things or a world of process. I believe, contrary to, I guess, the dominant opinion, that we live in a world of process. Then I will talk about life, and in particular I will illustrate what I mean by a world of process by telling you why we should think of life entirely in terms of process, as opposed to tendency to think of it in terms of things or mechanisms or other inappropriate categories. And then I'm going to actually spend quite a bit of the talk, I hope, unless I get very slow, talking about why we should care as humans about being processes and being in a species, indeed, which is a process. And I want to talk about some implications for what's special about humans. I'm not exactly a human exceptionalist, as the word is, but as a matter of degree, at least, I think we're a very unique species. And then I will talk about some implications for kinds of people, which I think are much better understood when we realize that we are processes. So probably process rather than organism is perhaps the central topic, but again, I shall spend a good deal of the talk talking about humans. So, substances or things, and substances is a sort of technical philosophical term. I'm not going to go into the technicalities. I can tell, I mean, there's a story to be told that goes back to at least Aristotle and could go on for several lectures about this, but really just think of a thing, and I'll say a little bit more about what philosophers mean by things, because it's not quite as simple as a kind of common understanding. But to go back to history, so let's start where we generally date the beginning of Western philosophy, 2,500 years ago, the pre-Socratic philosophers, and two of the pre-Socratics who have kind of come down to us as famous, I suppose it's an interesting historical process, are Parmenides and Heraclitus. And basically they said some perfectly opposite things about their general view of the world. So Parmenides is famous for saying change is an illusion. And Heraclitus said nothing endures, or indeed probably nothing exists but change. So everything is change. Now, I think Parmenides has kind of got a little bit of a hard row to hoe here, because we see things changing all the time. But I think where this leads is within a number of philosophers of this period, and I guess the most famous is probably Democritus, who interpret this in terms of an atomistic world. So there is change, but all there really is are these atoms and the space they exist in, and all that changes is the positions of the atoms, and possibly they're bumping into one another. So what we think of, the world we experience, is kind of an illusion. There's really just these atoms. They're the only things that matter. And this is, I think, an idea that really caught on. And particularly, I would emphasize in the scientific revolution, this is an idea that became very much associated with the scientific worldview. And I could have quoted a number of people saying similar things, but one luminary from the scientific revolution, Robert Boyle, wrote, "The naturalist, a scientist, in explicating particular phenomena, considers only the size, shape, motion, or want of it, texture, and the resulting qualities and attributes of the small particles of matter." So the idea, which I think is very familiar to anybody with experience of Western science, is that the ultimate goal is to understand what the sort of gross things we see are made of, and how the properties of those basic particles explains the properties of the big things that make them up. Some of you will no doubt be familiar with the concept of reductionism as a way of expressing this thought. But I think it's a thought that is absolutely basic to a great deal of science. And of course, one should give it some credit for that. It's obviously been a productive way of thinking for many scientists. But also, I think, a fundamentally mistaken one. And as a philosopher of science, I have no trouble with false views being very productive. That's, I think, is something we should have all learned from the history of science. But I think that in some respects, and this is perhaps an exaggeration, that this victory, which I call Parmenidean, the victory of Parmenides' view, was kind of disastrous for biology. Because, and this I'll go on to explain, I think we have to understand the living world is as composed of process, constant change, and not in a Parmenidean atomistic way. And I think we still have a very strong tendency to think atomistically. We're constantly looking for mechanisms, trying to understand things in terms of genes and molecules. And of course, there is much to understand in terms of genes and molecules, but not as much as some people have wanted to tell us. So the last bit in this very brief introduction to this central philosophical divide, I want to just say a little bit about what constitutes these philosophical views of things and processes. So on the one hand, things can be very big or very small, sort of atom, which of course we now think of as made up of smaller things, and a planet, quite a big one. And of course the planet is just supposed to be made up of lots and lots of atoms. The basic philosophical orthodoxy, which builds on this, but in complicated ways, is that we think of the world as made of things and the properties of things. So what we're doing in describing the world is listing the things and finding out what properties they have, and that those properties will include, powers to interact with other things and so on. As I say, this is now moving somewhat away from this underlying view, but this is what the underlying view is supposed to explain by saying what these big things are made of, how their constitution gives them these properties. And a characteristic part of such views is to look at what the essential properties of things are. What makes a particular complex thing, or indeed the simplest things, what properties make them things of that kind. And of course, in the tradition, that the properties that make something a particular kind of thing are typically structural, what it's made of, how its parts are arranged. So we'd start off with molecules being made of particular atoms arranged together in a certain way and so on. One thing about these things is they're autonomous. They don't depend on anything else for their existence. And I guess if you think of a paradigm kind of everyday thing like a chair, philosophers love to do this sort of thought experiment. We could imagine a universe that just consisted of one chair, nothing else. That was all. You might wonder how it got to be that way, but still, it's something that would seem to make sense because a chair can exist simply by itself. It has fairly clear boundaries, perhaps very clear boundaries, and crucially, its default state is stasis. What we typically want to explain, particularly scientifically, is why things change, why they decay, why they grow, this sort of thing. Now, this is all quite different from the process world. In a process world, every being existence is dynamic. The things that the traditional view sees, we think of in a process world as something like eddies. There's just this flux that makes up the world, and sometimes bits of the flux stabilize in ways that last a while and we think of as things. And I guess a kind of paradigm of this is an eddy, which we know to be a kind of stable formation which is maintained by a flow of stuff through and around it. And here I've zoomed in on a famous feature of Jupiter, the red spot, which is an enormous object which has existed, or looks like a thing that's existed for as long as we've had telescopes good enough to see it. And but it isn't a thing. It's basically is an eddy. It's a storm essentially, which is maintained by winds of several hundred kilometers an hour that flow around it. And if the wind stopped, there'd be no more red spots. So it's a paradigm of something that is only stable because stuff happens to keep it there. So again, this general idea of an eddy and the flux of process. Its boundaries are vague, and there's no obvious place where it stops and the surrounding winds begin. And so again, it's a crucial characteristic of a process. They require activity to continue to exist. So that's the basic background philosophical idea, but I want to spell it out by telling you why. First of all, organisms, and then the lineages that organisms belong to and come from have to be seen as processes. And I should say, again, particularly for those of you with a sort of background in more traditional philosophy, I'm assuming, particularly in the case of lineages, but certainly also in the case of organisms, a rather unfashionable category, which is the persisting process. On the whole, people think of processes as just made up of parts that stuck together, but not having a continuing existence. I think that what we think of as things are typically persistent processes. So, why organisms? And this is the bit that's in the title. So I think there are actually three reasons why everything I said about processes fits organisms, but what I said about things doesn't. I'll say a little bit about what to make of these three different ways in which organisms are processes. I think each of them is quite sufficient to show you that an organism is a process, but together, if you don't like one of them, you've still got plenty of argument for the conclusion. So, and I'll just go through all of these. I just list them here. They're metabolic processes, developmental processes, and symbiotic systems. And I'll say more about that. So, metabolic. This is a very familiar idea. We realize that people often say organisms are thermodynamically open systems far from equilibrium. What that means is that to maintain themselves as the structures that they are, they're constantly taking in energy from the environment and using it to maintain the structure. So they're certainly not autonomous because they need to have this flow going through them from the environment, and they're certainly not static by default. If this stuff stops happening, they're dead. A static organism is a dead organism. There are trillions of little things going on inside us every moment that contribute to maintaining us in the kind of structure and activity that we are in. Now, of course, that itself is changing at a different time scale because organisms are developmental processes. Now, this is something that's actually very hard to reconcile with another part of the standard thing view of the world, which is things having some kind of essential property. Because actually, if you look at the properties of an organism over time, they change massively. And one of the characteristics of an organism is its life cycle. I often like to say an organism is a life cycle. You know, we tend to think of an adult as a kind of paradigm, but of course, you know, the tadpole is just as much the organism as the frog. And we certainly think they're the same individual, but it's very hard to say they're the same individual thing when they have so few properties in common. Very easy to see that they're an individual process that goes on through time. Some little pictures of a couple of very familiar life cycles and one of the really weird ones that are characteristic of a lot of sea creatures. So again, the way that organisms persist is through this change, which is quite typical for many processes, but very hard to reconcile with much of the traditional view of the world of things. And finally, and I guess perhaps the most interesting, is symbiosis. We've all heard a lot about this recently, and we all know about our microbiomes and how crucial they are to our well-being and so on. And of course, it's all true. And it's true of just about every complex multicellular organism, that it's actually in a symbiotic relationship of some kind with multitudes of other microbial or microscopic organisms. Something between 0.5% and 80% of the cells in a human body are microbes, many of which are symbiotic, some of which are just hanging out in a nice, warm, soft place, others of which may be harmful. But most of them are good. Many of them are essential for our well-being. And there are many different stories one could tell about. I particularly like to talk about the cow, because sometimes at one point when I was really particularly interested in microbial life as something that had been massively ignored by people, at least in my neck of the academic woods, is to take a microbial view of the world. And if you take a microbial view of the world, a cow looks quite different. I mean, basically microbes can metabolize almost anything, whereas multicellular organisms tend to be very limited. But sometimes they need to set things up right. So basically all the metabolism of cellulose and similar things in a cow is done by bacteria, but they have basically two problems. One is it's ideally you do this in stages with different consortia of microbes, and the other is if you just have even all those consortia in one place, you've eaten all the grass and then it's hard, then you sort of die. So basically what you need is a bunch of vats connected by tubing and a primitive locomotive system, and you've got a cow. That's exactly what a cow is, basically, from the microbe's point of view. And plants, again, have a wonderful fungi play a particularly prominent role in plant life. I could love to go on about that, but the one thing I want to say is that, again, in theoretical biology and philosophy of biology, we've come to talk a lot about the holobiont as a way of talking about the whole system, which is made up of, in the case of multicellular organisms, the multicellular organism and all its associated microbes, which include bacteria, fungi, some larger microbes, and so on. And the reason for this is that actually, if you're interested in how the system works, that's what you need to look at. Traditionally, we tend to think of an organism in biology as like a cell and its descendants. So we have a gamete, a fertilized egg, and a whole bunch of cells that descend from it. But that's not sufficient to understand how the whole system works. To do that, we need all the other participants. And if we think of an organism in the first way, we can certainly say that very few organisms are autonomous. I should say there's a whole different story to tell about the microbes themselves. I'm really sort of avoiding microbes and just talking about big organisms, which I sort of hate to do. Happy to talk about microbes in the discussion if you would like. At any rate, as traditionally conceived, organisms are not autonomous, but if you consider the holobiont, you actually have all kinds of different entities with different time scales, many flowing through the system. So again, you've got nothing like a traditional thing. So, processes, and this is just a kind of bottom line of this part of the discussion, processes get entangled with one another. And this is why symbiosis is such an interesting phenomenon, because it's very hard to understand how things become entangled. You can twist them together, but they're supposed to have these boundaries, and so you haven't really mixed them, you've just kind of got them all kind of hard to separate, hard to trace the boundaries. But you don't abolish the boundaries of a thing by mixing it up with another thing. You wrap a piece of lots of string around a chair, and you've still got a piece of string and a chair, though it may be quite hard to separate them. But processes live often in this entanglement. Processes are stabilized out of the flow, and they're stabilized typically, and this is clearly the case for organisms, both by the properties of the bits, the constituents, but also by the context with which they're constantly interacting. So, again, this is, I often like to use examples of rivers because, I guess partly because Heraclitus is most famous, I'm sure you probably know, for this rather unfortunate line about not stepping into nobody steps into the same river twice, which isn't strictly true, of course, but it would be if you didn't know that the river was a process. But one of the things that you can see very easily in a river, and particularly in complex bits of rivers like deltas, is that how you divide it into separate entities is fairly arbitrary. You know, how wide does a bit have to be to become a lake? You know, when's a tributary another river? Which is the main river? Which is the tributary? You can, Mississippi is a lot shorter than the Missouri, but there's more water goes down. So, I mean, you could just do it all kinds of different ways. And that, I think, is often what processes are like. And I think that is even what life is like, that things are so much entangled that you can talk about for certain purposes, you talk about the traditional organism, just one cell lineage, but also you might want to talk about the holobiont for other purposes, and that's fine. There are different ways of carving things out of the biochemical flow. Now, the other concept that I think is absolutely essential for understanding biology is the concept of a lineage. And the reason for this is basically lineages are what evolve. So organisms, however you define them, don't evolve. They develop, but they don't evolve. Evolution is something that happens to a sequence of organisms, which I'm calling a lineage, a bunch of ancestor-descendant group of organisms through time. And an evolving lineage, and there's a quote from one of the great 19th century evolutionists, G.G. Simpson, a lineage is a sequence of species. Basically, if you just, if you trace back from us, you go back, through ape-like species and then little mouse-like species. This whole sequence going backwards is a lineage, and bits of it are species. And again, I just note, I mean, one of the things of this is that this concept of a species doesn't apply necessarily to microbes, which is an interesting fact. Again, I'm happy to talk about that if you would like later. So what is a species? Well, I'd say it's a bit of a lineage, but there's a very, in my particular field, one of the most shocking theses that was defended in the sort of 80s and 90s of the last century by these two guys I've illustrated in this slide was that species were a kind of individual. And the whole history of philosophy has seen species as paradigmatic terms for classifying individuals. So that's kind terms. But what Hull and Gieselin pointed out or claimed, and which has been very widely accepted after a lot of early resistance, is that actually we should think of them as individuals. And I think one of the reasons that people struggled with this is when they're told there's an individual, they tend to think that's an individual thing. And all the members of a species can be wildly separated, not interacting with one another. That doesn't seem like a thing. But once you think of it as an individual process, I think there's no problem with that at all. Lots of processes have separate parts. I mean, battles, economies, these are the parts don't have to be in the same place. They can be as separate as you like, but they interact to maintain some kind of stability. And so that these are the processes within which evolution happens. Now, one of the things I said about individual processes is they need some activity to maintain themselves as individuals. And we saw, with the organism, this is typically metabolism, all the chemical processes that maintain the individual. So what's the equivalent for species, or more generally for lineages? And the main answer to that, I think, is natural selection. And in fact, if you think about the way Darwin talked about excess production and selection of the kind of optimal organisms, the fittest organisms, what that really, one way of understanding that is maintaining an entity, the lineage, the species, that consists of these very similar individuals. And actually, and here's where I'm very heretical to some biology, I think that this is really the important role of natural selection. I don't think natural selection is very well thought of as a cause of change. Indeed, you might say it couldn't possibly be a cause of change because selection has to have something to select among, and natural selection doesn't provide alternatives. It just selects from a given set of alternatives. But at any rate, that's certainly one thing that maintains a lineage as a coherent whole. Another, and again, there are some problems with microbes, though possibly microbes are more like that than we thought. Another thing is sex. What sex does is create the flow of genes within a lineage that maintains its distinctive characteristics, and to some degree, and of course, as some of you also know, there's a huge amount of hybridization between related species. So it's a fuzzy boundary, but it's a quite good enough boundary to maintain many divisions. And then finally, and I think this is something that leads towards very naturally the talking about humans, cooperation within a lineage can be a very strong stabilizing feature. This is something, so the nature of species is something that actually has evolved over time, and cooperation is perhaps the most recent feature that's evolved that contributes to the stability of some species. And if you look at the most cooperative species, ourselves and the social insects, they are some of the, perhaps the most successful lineages on the planet, and arguably this is substantially attributable to the fact that they're the most cooperative species on the planet. So let me now say something about humans. And I put this parenthesis because I'm not sure whether this is something that is often rather used somewhat abusively to sort of humans. People like to say we're just an organism, and in some sense that's true, but in other senses we're pretty unusual, even a unique species, and I think there's nothing wrong with whether, I don't want to be normative about it, we may be a terrible species, and that many people think the world would be a much better place without us. But we still, that's another way of saying we're quite exceptional, because those people tend to think most of the other species are great. It's just us that is a problem. So, first thing, and I make a reference to this wonderful work by the biologist Mary Jane West Eberhard, who has written this encyclopedic work on developmental plasticity. And this is a really important phenomenon, much ignored by a lot of traditional biology for reasons I think I won't go into here. But what is assembled is all this information that shows us that development is not the unfolding of a totally predictable program. In almost every organism, it's subject to a great deal of plasticity, often plasticity responsive to the environment in adaptive ways. Now, humans have a particularly fascinating developmental plasticity, which is behavioral. So different, we just need to think about, how the people we know, the different things they do, the different skills they acquire, to realize that there is an enormous variety of developmental trajectories for humans, particularly with regard to behavior. And many factors influence these, and this is fairly obvious, just as indeed is often said to be the job of philosophers, just reminding people of things they know, but don't always think about. But the factors, we know that that genes affect human development, of course, but also that acquired changes to genes, called epigenetics, is very important, and that also we sometimes forget that there's more we inherit than just genes. We inherit a whole egg full of all kinds of interesting chemicals. But then we also have different upbringings, different social interactions, and we even have a kind of feedback loop where the way we behave affects the way we continue to develop. And generally, there's a much wider social and physical environment, including the built universes that we inhabit. So there's all these factors that are very diverse across humans and lead us to very diverse outcomes. And what that enables, to do that, was something that, sorry about that, is what I think is perhaps the most distinctive feature of the human species, the division of labor, which is an absolutely decisive factor in the kind of at least at some level, enormous success of the human species, that it enables us to live in all kinds of environments. And as I say, I think we don't reflect on this, I think, enough, nearly enough, actually, because we have this rather toxic tradition, I think, in recent history of individualism, where we tend to think very much in terms of the individual characteristics, virtues, vices of one another. Now, I'm not saying we shouldn't think about those, but we should also remember, I get to stand up here and pose as some kind of an expert, which I hope I am on something or other, but I couldn't be here if countless other people didn't provide me with food, clothing, transport, warmth. There's a whole host of things, and of course not to mention books. There's thousands of different people whose work is necessary for me to do the kind of what passes as work among academic philosophers. So I think one really can't exaggerate the extent to which what people can do is a consequence of the diversity of people doing different things that enable one another to do this. And I say I would trace this back, and I'll elaborate on this a little bit more, to our being these very flexible processes. Far from being a kind of predetermined thing unfolding in a program, we have this ability to develop in all kinds of ways to serve different functions in the human species. And I think a huge number of the problems that we have arise because we tend to interpret human diversity in terms of different kinds of thing. And I list a few: workers versus professionals, men versus women, manual workers versus whatever people who don't work with their hands do, manual. Rather than look at the hugely diverse developmental histories that enables that these categories just loosely divide in various ways. And I really love to quote my favorite authority on this, because he's such an unexpected person to many people to say this, who's Adam Smith. And I hope you'll excuse me for reading at length from one of my favorite quotes from this wholly and grossly misinterpreted thinker. So Smith writes, "The difference of natural talents in different men is in reality much less than we are aware of. And the very different genius which appears to distinguish men of different professions," this is sexist language, I hope you'll excuse, "when grown up to maturity is not upon many occasions so much the cause as the effect of the division of labour. The difference between the most dissimilar characters, between a philosopher and a common street porter, for example, seems to arise not so much from nature as from habit, custom, and education. When they came into the world in the first 6 or 8 years of their existence, they were perhaps very much alike, and neither their parents nor playfellows could perceive any remarkable difference. About that age, or soon after, they come to be employed in very different occupations. The difference of talents comes then to be taken notice of, and widens by degrees, till at last the vanity of the philosopher is willing to acknowledge scarce any resemblance." And I think that's exactly right. That of course, there are differences in capacity, but they're not anything like as definitive, as decisive as we often think. So, I have to mention one other aspect of this, because this is something that is again so distinctive of our lineage, and the lineage that enables these different developmental processes. And this is something that's being quite widely discussed by evolutionists nowadays, niche construction. So I give another classic example, which is the beaver, which constructs, basically landscapes its environment in a way that provides exactly the niche that it's adapted to. But actually, pretty much all organisms have some effect of their environment. So contrary to a common view that somehow evolution is just a response, a passive response to the environment, it's very much a two-way process in which the organism, the lineage, shapes the environment, and the environment that it shapes provides a context for the evolution of the lineage. Indeed, Darwin wrote one of his most fascinating books about earthworms, which has, I think, very much this message, that the earthworm is basically an aquatic creature that manages to live in the soil by maintaining its humidity, by bringing all this organic matter, making it very water retentive and so on. So that's another very different example. But of course, here I've emphasized, I could have just shown pictures of cities which we live in, but also these cities contain things like schools and hospitals that are very fundamental to our development, the distinctive ways in which people develop. Okay, so I think, again, this comes to the not really unique exceptionalism, but the very exceptional characteristics summarized of the human species, the behavioral plasticity, the division of labor, the multiply constructed niches, constructed, I think I should have said, by over historical time, not just by living individuals. And I say I don't think they're differences in kind. You can find precursors of all of these things in other species, but they're certainly differences in degree. And in some ways, I say the closest, the most similar perhaps are social insects, but they're very different because they do have a sort of more or less genetically determined kinds. And of course, there are many fewer developmental kinds. It's even there, it's a bit more complicated. And what these factors permit is our unique sociality and social cohesion, which is so fundamental to the enormous success of our lineage, at least success in terms of at least there being lots and lots of us and absorbing, using most of the resources of the planet. And I just think it's very ironic that somehow for the last couple of hundred years, we've had a very dominant ideology of individualism, that the success of the human species is this competition between isolated individuals. And it just seems nothing could be further from what is unique about our species than that, even if maybe there's a role for that somewhere. Okay. So, finally, I want to talk a little bit about human kinds, because I think the classification of humans into different kinds, of course, looks very different to when you start seeing them in terms of these highly diverse processes. And as a result of this developmental diversity, we are very diverse in our habits and our behavior, our lifestyles, and we can divide ourselves up into all kinds of different categories. The features that form the basis of these kinds, as I've said, have multiple causes, and there are various effects of having these features, and indeed of being classified. And one of the most interesting philosophers of science of the last 50 years, Ian Hacking, talks a lot about how classification of humans actually affects how humans are, that people respond to being classified and develop distinctive behaviors in response to this. But I can't really go into that now. So what I want to say, and this will be the last topic, is that we should be really suspicious of general claims about the implications of belonging to such human kinds. And again, this comes back to the difference between classifying the world into these distinct kinds of things with their distinct essential properties and seeing all these very diverse processes developing in very open ways within this general flow of activity. So, So humor, so let me, I guess the most controversial, one of the two most controversial ways of classifying people. I'll start off and dive in where angels fear to tread, say a little about sex and gender. So I'll talk about sex gender, which is a term that is used by, I think, one of the most authoritative speakers on this topic, the American feminist biologist Anne Fausto Sterling. And the reason that that's I think is a useful term is because of the real intertwining of the kind of different factors that lead to these distinctions. So as a starting point, we have a very familiar idea of two genotypes that lead through a kind of developmental process to heterosexual, normatively gendered. By normatively gendered, I mean following a certain kind of normatively expected way of behaving as belonging to these two kinds. Many factors contribute to stabilizing these trajectories, including genes, hormones, brains, parenting, and the wider culture, which provides some of these norms. But of course, there is a lot of variation all along the trajectory, which again is something that we may either welcome or deplore according to our view of these things and how we see the normativity that goes into these. But the possible outcomes empirically is very wide. I guess what I'll say at this point is there is in fact huge inter and intracultural diversity in the expression of gender, i.e. in what the possible outcomes of this sort of roughly bifurcating, but actually multiplication. So, it's a very banal point, but just, we certainly know that there are systematically different inputs into these processes to maintain these two. This was one I just really liked. I happened to come across this artist, a Korean artist, who went around collecting all the possessions of boys and girls in the US and Korea, and came across with a lot of very lovely pictures like this. And it's a nice case because, as it turns out, pink only became a female color in about the middle of the 20th century. Historically, red and pink are all just virtue variants of a very masculine color, and then they trace ways in which various people said things that were very influential and changed this round. But anyhow, nowadays you can find this sort of division, and you can find it in other cases. I happened to, just when I was looking at this, I came across this picture of the German Olympic team 12 years ago, which I guess, and of course, this is a very trivial example, but I guess if anybody doubts that there are not always visible systematic differences in the way we bring it up that lead to this bifurcation that is widely observed. Now, and I guess all I really want to say is I think that a lot of the kind of thinking about this is grounded in the idea that there are really two different kinds of things, differently structured, differently, mechanically different. And in the extreme, you come across, say, men are from Mars, women are from Venus. The point of that, I take it, is to say they're really radically different kinds of entities. But if you see them as just snapshots of a particular stage in a very variable process of gender differentiation, we have this process, which is partly cultural, partly biological, of differentiation, normatively channeled into these particular ways, then that's a very different view and should lead us to see the diversity, I think, in a more positive way. And I think, so it's, I put it as a case where thinking in terms of kinds of thing is really quite detrimental to thinking in a helpful way about this. And just to say, it's not just the kind of ordinary uneducated who have this sort of mistake. I was very interested to come across something I read in, obviously I'm an academic, I read The Guardian. So I came across this lovely quote some years ago. So a researcher at the University of Pennsylvania said the greatest surprise, so obviously these are fMRI pictures of male and female brains at a certain age, said the greatest surprise was how much the findings supported old stereotypes, with men's brains apparently wired more for perception and coordinated actions, and women's for social skills and memory, making them better equipped for multitasking. And I just, there's really, I think, only one very simple thing that needs to be said about this. Why on earth would you imagine that the wiring of the brain is cause rather than effect of gender difference when you reflect on the differences that that developing men and women have experienced in their lifetime? Of course their brains look different, and of course they look different in ways that reflect the expectations of normative gender. So that's really, now I'll be very quick, I think, with this next slide, because it's a bit complicated, but I'll just summarize. I mean, there's a standard biological picture here. We have evolutionary pressures, some of you know kind of things that evolutionary psychologists say, that produce these sexually specific genes, that produce differentiated brains, that produce gender-specific behavior. It's a very linear story. It's a story about how certain kinds of things come to be a certain kind of way. And all I just really want to do is it's so simplified, because each of these stages has multiple causes of the transition from one to the other, and indeed, not just in that direction, but there are all kinds of ways in which, for example, just to start at the bottom, gender-specific behavior produces sexually differentiated brains. So, it's just that the whole story has to be much more complicated. And I think in a world of flows in which we just see these forms emerging in various ways from the flux, makes it much easier to make sense of this. Yeah, okay. So very quickly, and just because I'm trying to be as controversial as possible, I'll say something about race. I'm getting close to the end. I hope this is not overrunning time. So, and I think very similar things. So what race, fundamentally, I think, is a cultural systems of divisions, basically used to discriminate negatively against some groups. It's a possibly controversial first statement. Now, it's often taken to map onto biological kinds, and there is a certain basis for this, which has become very notorious because of some genetic work, which is often taken to back this up. And what it does back up is, I think what I'm saying here, is there is a history of human migrations. There is, people have moved around the world, and groups of people moving create a kind of lineage, a kind of sublineage within the human species. But what is the first thing to note is, of course, these lineages are very rough, very much intertwined with their surrounding humans. I mean, it isn't as if 60,000 years ago, a bunch of people got together in Africa and said, well, let's all go to India. People drifted in a certain direction. They were, and as they drifted, they interbred with, intermingled with, shared their cultures with people they met along the way. Well, not 60,000 years ago, because there was nobody there. That's the beginning of migrations out of Africa. But at any rate, these tend to be deeply intertwined and just reflect statistical tendencies in the movements of humans. And you can more or less track these to some extent by looking at distinctive genes that appeared in the course of these sorts of migrations. But most such migrations probably didn't actually produce any distinctive properties and were just lost. And actually, one example I think I put on the next slide. My family liked to describe itself as Huguenot, and what that means is they believe that one of my ancestors 350 years ago was a Huguenot expelled from France for religious reasons, probably in 1685. Since then, I would have probably about 400 ancestors. So it doesn't really make a very significant aspect, but also because on the whole, Huguenots were pretty well integrated in society, I have very, very little genetic or cultural residue of being a Huguenot. There are tiny pockets in the world where Huguenots have kind of maintained a little cultural integrity, which is very nice, but I'm not part of one of those. So actually, let me then get to this. So the reality of race, on say, is this residue of this kind of ancestral origin through migratory populations. But generally, these merge into the wider population and leave very limited trace. But of course, if they leave a trace, why is that? Because there are barriers to integration, particularly reproduction. And if there are sufficiently strong barriers to isolation, then you can have a more stabilized lineage, which is more distinctive. And to some degree, this does happen where you have, as I say, actual social obstacles to integration. And so I want to say, on the whole, racism causes race rather than race causing racism. And that's because the lineages that survive are the ones that are identifiable because they've remained separately distinctive. So I want to say biological race is a kind of static, frozen legacy of this historical process of hostility to immigrants, basically. So finally, really finally, this leads to, I guess, another, sorry, summary there. And I think people have recognized that there's very little biological significance, but what there is a kind of residue of migration and social discrimination. So finally, we might, and this really is finally, I'm sorry, I'm going on a little too long. We might ask, well, what about cultural kinds? Because there are countless ways of classifying people, including some that are vaguely racial. I put an African American because it's a nice semi-racial classification. But now, these can, of course, also ground lineages, actually very often ground lineages. As, for example, we know that the Huguenots that actually did, there's a little pocket in South Africa. There's one Huguenot church I managed to track down in North America. So, and these carry with them cultural properties that kind of distinguish people from the wider species in particular ways. And I would say this seems to be a very nice thing, actually, to have lots of cultural lineages if they're just maintained positively by traditions, by crafts, by all arts, crafts, kind of all kinds of particular practices contributing to the general diversity and resources of the human species. Until, prior to globalization, national identities no doubt provided pretty robust cultural lineages because people did tend to stay within their culture, their nations, and that could be a perfectly positive thing. I think now I have to say contemporary nationalism is, on the whole, to my mind, less positive, but I mean, it certainly has something to say for itself. So I finally just end with a sort of thought. I wonder whether we could become a self-directing cultural lineage as a species. And the reason I ask this is because it seems to me that perhaps if we did this might be the only way of actually surviving such existential threats as climate change that we currently face. Because ultimately, these are global problems, they're problems at the species level, and we have really never, ever acted at the species level. But now faced with niche destruction, could we do it? And I borrow a little quote, maybe I shouldn't read this because I think I've been going on too long, but I came across a nice little quote of a very small scale of how process thinking might enable us to have such a view. So just a little bit, we're connected to a community that transcends time. We're connected to the first Indians who walked on the earth, and we're also connected to the ones who aren't even born yet. Anyhow, I won't read all of that, but just to say, people have sometimes thought in terms of membership of a lineage that transcends time. Whether the human species could imaginably think of itself like that, I think is pretty optimistic, but it might be that that's what we need to do. So I won't go really through all this. I say we have place in complexly differentiated biological lineage. We should understand human diversity in relation to lineages, but all of these contain a great deal of internal diversity. And just finally, very last slide, just to sum up what I said. We live in a world of process. We are processes. We're processes that are part of a bigger, long-term process. And we should, I think there's a lot of insights, particularly about the strangeness of the individualism that we're so fond of, that can be gleaned from recognizing ourselves as processes. And sorry to have, I say, gone on a little longer than I meant to, but
Thank you very much indeed, John, for giving us such a radical, different viewpoint of reality. And obviously, you mentioned all the things you shouldn't really mention at the dinner table. Race, gender, sex, and you finish off with cultural kinds. So I think this will give us plenty of thought, food for thought, and probably quite a few questions in the audience today. I suggest I've got a few questions online already, but I'll always start in the room first to give you first dibs, and then we go online.
Thank you for the really interesting talk, and I particularly enjoyed the pro Adam Smith thing, because I've been researching the history of economic thought, and I couldn't agree with you more. I wanted to, if I may, throw three names at you that weren't in your talk and work out sort of conceptually how they fit with you or not at all. A.N. Whitehead, does process philosophy kind of come from him? Ian McGilchrist, he talks a lot about, the matter with things and the different sort of ways of seeing the world. Does your philosophy fit in with that? And then the other is Richard Dawkins. I heard you say that, we look for mechanisms and genes. How wrong was the selfish gene, and how much damage has it done if it was wrong?
Okay, thanks. So Whitehead, I was actually talking to Andreas before. I mean, Whitehead, there's much to admire, of course, as a process philosopher. There's also a problem I have with Whitehead, is he has an awful lot of jargon, and sometimes his writing is not the most lucid. And if you think his big book on process and reality is the gateway to process philosophy, you'll probably never make it to process philosophy, because it's a huge impediment. It is one of the least readable books in the philosophical canon. There is also a little technical thing, which is a little nasty and not really very fair. But in a certain way, he's not really a process philosopher, because he's a kind of atomist. His philosophy is of atomic events, and in a certain way, I think but that's a little technical. The real problem for me with Whitehead is, well, I guess the other thing, as well as all this technical language and weighty prose, his philosophy is very mixed up with theology and panpsychism, both of which are things that I prefer to steer clear of. So there are a lot of reasons why I don't, but I also want to say, of course, he has to be given a lot of credit for defending pretty much process philosophy at a time when it was certainly not very fashionable. McGilchrist, I mean, yes, I very much, I think his recent books are so large that I can't say I've quite got to grips with them. I've had some correspondence with him, and I think we're very much doing compatible things in all kinds of ways, but I haven't yet quite figured out, where the biggest agreements are and whether there may be some big disagreements. But he's certainly somebody that I think is in the same line of work. Dawkins, yes, I do. I mean, actually, funnily enough, I've never done this before, but I just reviewed his latest book. So I've been thinking about Dawkins a bit. So here's my latest story. I mean, the selfish gene was a really timely expression of a view of evolution that was, it was a sort of an extreme statement of a view of evolution that was very much of its time. And of course, he writes beautifully, has lovely examples all the time. So there are many virtues there. And actually, his next book, The Extended Phenotype, extended his ideas in interesting ways. So subsequent to that, I guess it seemed to me he's slightly in the business of demonstrating that a fit idea should keep on being replicated as much as possible, and has written more or less the same book as The Selfish Gene many times since. And unfortunately, the problem with that is the environment has been changing. So I feel his books are becoming increasingly less adapted. And I think the view of evolution is really no longer defensible. We know much more about the limitations of the gene-centered view than we did in 1976. And we know about other evolutionary processes that matter. There's a whole kind of panoply of things like epigenetics, I mentioned, niche construction. I mean, there's the whole thing we now tend to call the extended evolutionary synthesis, which is a way of saying there's a lot more, it's a much more complex story. There are many more processes going on. And basically, Richard Dawkins thinks nothing has changed. And that's quite explicitly, he gets very exercised and quite heated at the thought that anything really has remotely comparable importance to the differential selection of alleles. And I think he's just wrong. And unfortunately, because he writes so well and people love reading his books, I feel he has perhaps an increasingly damaging effect on public understanding of evolution.
Ooh, contentious or what? Right, we've got another question here.
Well, it's not a great question, just following on from what you said about Richard Dawkins, is that he was the guy who first developed this, the name, the meme,
Yes.
which was taken forward by Susan Blackmore, who wrote a book.
Yep.
And this was all happened before the internet. And now I remember went to a lecture really before the internet was really got going and before social media. And now people, this idea of a meme, it's a very common, everybody's taught, knows about it. Back then, it was something really quite new. So really Dawkins' ideas that following through there, they have been brought forward by other people, their understanding.
Yeah.
So saying that Dawkins is somehow just stood still, maybe for him, but people have taken his ideas and brought them forward.
Yeah, that's absolutely true. I suppose I have to say that I'm not a huge fan of the meme concept. It seems to me that it's so I mean, in a different voice about Richard Dawkins. I mean, I guess my prejudice against Richard Dawkins, if you like, is I think he's very much living in this, what I refer to as reductionistic bottom-up world, in which explaining everything in terms of genes makes a lot of sense. It's an atomistic view. It says there are these bits that are what really matter. And when we look at stuff at more complex levels, what we really understand is how these underlying kind of causal entities made these things happen. Memes is a way, I think, of applying that concept to culture in a way that I think is even more reductive.
The feedback loops.
Sorry?
The feedback loops. The meme is successful. Therefore, it gets bigger.
Yeah, but you've got to start off by kind of it provides a sort of cultural atom that, and I don't think there really are cultural atoms. What elements of culture are deeply integrated with one another, and their persistence, I mean, as I kind of talk about the entanglement of process, their persistence is not, independent of other parts of culture. You can't break down culture and say, the culture of Southern England contains the following 846 memes, and just list them, because all of them are tied to one another in ways that make sense only in relation to a whole bunch of other. So cultures are very complex things.
Okay, and there's plenty of memes swirling around the United States as we sit in this room.
Indeed.
But that's a slightly more modern interpretation of what a meme is. This gentleman there in the middle.
Considerable interest at the moment in artificial intelligence. Right, there's considerable interest at the moment in artificial intelligence. Where would you put that in your product or process? I saw that.
Yeah, no, I mean, I'm just, I don't really know where to begin, because it's not, I'm not sure that I understand artificial intelligence very well. I'm still kind of possibly of the old school that thinks it's possibly just an oxymoron, but, and looking at its, at its products, I guess not sure I yet see a lot of intelligence. But I think honestly, I should just pass this one on the basis of ignorance. I don't think I know enough about what artificial intelligence do. I mean, I think, the kind of chat bots and things we see now seem just not terribly interesting. I mean, they will be interesting if they manage to, for example, put lots of people out of work. I mean, that will be, whether that's good or bad depends what we do with the unemployed people. But that's a huge social question. I mean, and I think, so the consequences of the technology are hugely interesting, but I just don't think I know what they will be. And I think it depends so much on politics and how we respond to it. I mean, I guess I'd be rather pessimistic in a political situation in which we seem to be largely in a process of sucking all the wealth in the world into an ever smaller number of people. I can see that artificial intelligence might be a new way of accelerating that process, which would be catastrophic. But that's, I don't understand it well enough to know how much of a risk that is, or whether that's how it will actually play out.
I suppose the only thing I would say to that is that with generative AI, rather than GoFi, good old-fashioned AI, and also neural nets, then you would actually classify artificial intelligence itself as a process rather than a thing or an individual.
Well, yeah.
Which would be quite interesting. Yeah. And where that process leads is the big unknown. Yeah. Anyone else in the room before we start? This gentleman here at the front. Again, just please talk directly into it.
Does your critique of individualism have implications for individual human rights? For individual human rights?
I don't think so. I mean, I think that it's not, I tried to say, this isn't, I don't want to say there is no, I think individuals are very important. It's just that I think we misunderstand, we attribute things to them that are not the right things to attribute to them exactly. But I think exactly the right things are individual lives that have value to people, and that value can be protected with rights. It's just the politics of competitive, I should probably say competitive individualism, but the idea that somehow the people get, that you justify the distribution of goods on the basis of just massive differences in the value of individuals. So in a sense, I say almost the reverse, that what I'm saying is there aren't these massive differences in the value of individuals that competitive individualism tells us. And so that actually it's a much more egalitarian view, the process view. And in an egalitarian view, the individual has as much right as any other individual to certain consideration, possibly even positive rights to things like, shelter and food, which is a very unfashionable, I think, aspect of rights, not just the negative rights not to be interfered with. So I think actually, I tend to think the reverse. I think it's that's the individualism that justifies inequality by saying individuals just have their own, have a total, the value that they have is entirely produced by their own individual merits. So I think I would say almost the exact opposite, yeah.
Okay.
But I see.
Okay, so we've got quite a few questions online now, so I'm just going to go online for a bit. One from Trevor here. Perhaps too basic a question for a philosophy presentation, but how does all this help us to live and live together?
Well, I guess, I hope I just said something about this. It helps us live together by seeing how interdependent we are. And I think if we take more seriously our interdependence, then we should be more serious about figuring out how to live together. So that's one aspect of how it helps us live together. I think, and I think I think one of the most, I do think that the most toxic political views do tend to come from seeing people as belonging to different kinds in the traditional kind of different kinds of thing with different essences. So I think in that regard, it is really important to think differently. Now, one can, and I have to say, because I was thinking, I was a critic of essentialism long before I realized I was a processualist. So I don't think, but I do think that the right way to fit out a kind of world view that is strongly opposed to that kind of essentialism is a processual one.
And we've got another one. Hi, John, great talk. I wanted to ask you what you thought about applying process philosophy to something like technology. How would it change our analysis to think of, for example, an iPhone as part of a process?
What?
How would things change if we considered something like an iPhone as a process rather than a thing in itself?
Right. Gosh. I mean, I think perhaps the entanglement of people with iPhones is something that I sometimes find quite terrifying. I mean, I think, and this actually relates to a lot of thinking in the philosophy of mind, philosophy of cognition, the kind of externalism about the mind. I don't know if people are familiar with this idea. So this comes back from sort of simple ideas like, if you're particularly, perhaps if you're suffering from memory loss, you might find you can work just like anybody else if you carry around a notebook and write down lots of stuff in your notebook. People argue that this is just the same as your memory. It's just externalized, but it's part of your mind. So your mind is not all in your head. Now, I think the iPhone is a much stronger case in some ways of part of your mind being outside your head. And I think that it's almost become symbiotic with, I mean, I see people in ways that I find quite disturbing, seeming to be kind of plugged into their iPhones and going around the world looking all the time. I mean, I know the number of hours that people spend on their phones doing things, I guess. And I hate to say it, but probably being, coming back to my political views about, being strongly manipulated by corporations, politicians, who, because the business model of the iPhone essentially is to sell information about people, or at least of much of the internet. And people want that information because they can sell other stuff to you. I mean, there's a whole world that people are tied into through these things. So I think this is certainly a rather negative example of processual entanglement, but I think it's probably should alert one to the potential dangers. I mean, I'm really delighted to see some schools at least having the iPhones checked on the way into school. It seems to me that that's thoroughly good idea. Because as I say, I think it's not just there's the person and there's the other thing that they interact with. It's really something that becomes so deeply entangled with their cognition and affect.
Okay, we've got time for one more question in the room, and then we'll draw things to a conclusion. You can have a go. Well, if you're quick, then I can let the other guy have a go as well. No, you're...
Thank you. I'll be quick. Thank you for the talk. For me, at least, I don't know anything about naming philosophers or anything like that. Mm-hmm. Some of your stuff sounds counterintuitive, and other things sound like you said you like to do is, remind us of the bleeding obvious. But however, isn't what you're looking at and your three Greek philosophers only looking at the same physical world at different scales? So at the level of strings and bits of energy and data, information actually popping in out of existence at the subquantum scale, all the way through to cells and organisms and iPhones and voters. At the moment, they touch a button on a screen. Is another set of scales, and as you zoom out, you see galactic clusters. So at the lowest level, you see process, but at the galactic cluster level, you see things. And all you're describing is, with your philosophy, is a section of that scale from the subatomic to the galactic.
Right. It's a very good question. It's basically looking, are they looking at the same thing just differently? It's a bit like quantum mechanics and relativity.
Well, I guess what I would say is I think as a process philosopher, I do look at them just as different scales at which different patterns emerge. But I think the philosophical tradition looks at them very differently, because the tradition is, again, to use this word again, reductionist. The tradition says that to understand the higher levels, you have to understand them via the lower levels. That the objective in understanding, an organism is to understand how the mechanisms that are put together to form the organism, and then you have to understand the components of the mechanisms and so on. I don't think there's a privileged level. I think that to understand that any level you zoom in has its own particular characteristics and ways that patterns form within it. So that, I think, is where I would say there's a big difference between those ways of looking at it.
One final question.
Yeah, thank you very much for the talk, which I really did find very interesting and stimulating. I think most of what I was just going to ask about has just been asked about in the question before. But I was going to preface it by saying I thought the interesting thing about Dawkins' book, The Selfish Gene, was that he turned evolution sort of upside down, the way you looked at it. Instead of organisms passing on through genes, it was genes that drove organisms. Now, in the same way, I wonder whether, as the gentleman before said, really process and things, they're either two sides of the same coin, and that you need to be both Parmenides and Heraclitus in the way you look at things, because if you don't, you're going to get a false view.
Well, I guess it seems to me that they really do contradict each other. I mean, that they have different views as to what the world is like. And again, I would say, so with Dawkins, I mean, probably the biggest movement against the Dawkins view is the increasing acceptance of multi-level selection. And multi-level selection is just not compatible with gene selection. And actually, you could go right back to, I think, 1960s, where people like Richard Lewontin were talking about how to understand, I think, meiotic drive, which is basically a gene that really is selfish, a gene that dominates its representation in the gametes, and so it spreads at a massive rate. The only meiotic drive genes you ever find are ones that are really harmful, because if they're not harmful, they're not genes anymore because they're uniform throughout the species. But now you do find, and there are very well-known examples of extremely harmful genes that drive themselves through this process. To understand what happens, then you have to look at two completely different processes. There's the negative selection for the organism that has this gene. There's the positive selection for the gene that is doing this driving. And actually, in Lewontin's example, there's some group selection going on, which explains why the maths didn't come out right. So you've got these three levels of selection happening at the same time. If you try and do at least a Democritean view, where everything ultimately is the atoms, you can't make sense of these processes that are driven by entities at these different levels, I'd say. And that's what Dawkins is trying to do, and he can't. And to try to say a lot in too much.
But I think, unfortunately, we've now reached the watershed moment of 9 o'clock. It's time to wrap things up. But before we do, please put your hands together for a very interesting talk by Professor John Dupre. I think Don